Welcome everyone. In this model, we are going to master something that separates casual AI users from real AI engineers and architects. Most people type random prompts and hope the model gives a good answer. Professionals don't do that. Professionals design thinking. In this course, you'll learn three powerful prompting techniques that structure the way AI thinks: plan, then solve, decomposition, and tree of thoughts. These are not tricks. These are cognitive frameworks. The same mental models used in consulting, engineering design, and scientific problem solving now translated into prompting. By the end of this session, you won't just ask better questions, you will control how the model reasons. I'm excited about this. Let's start. The first technique in our list is plan then solve. We are going to see a project proposal example. Let's begin with the first technique, plan then solve prompting. This is one of the most underrated but most powerful methods. Humans don't jump straight into complex work. We first plan and then we execute. But most prompts skip this planning stage. A plan then solve framework forces the model to first design a solution strategy before generating the final answer. Here is the structure. First, you explicitly ask the model to plan. Only after that, you ask it to solve. In this example, instead of saying write a project proposal, we split it into two phases. The planning phase defines the sections, structure, research, and the narrative flow. Only after the plan is created, we move to execution. This dramatically improves the clarity, completeness, and logical flow of the result. Think of this like asking a senior engineer to design the architecture before writing the code. You are converting the AI from a text generator into a problem solver. Now let's push this into a real-world scenario. Here we are analyzing a 20% drop in customer satisfaction. This is not an online question, this is a business investigation. So again, we separate two mental modes: planning mode, what should we investigate, what data do we need, and what frameworks will we use. Execution mode, only after proper planning, we actually analyze and draw conclusions. This approach avoids shallow answers. Instead of random guesses, the model builds a structured investigation path. This technique is extremely powerful for root cause analysis, incident investigation, strategy documents, technical designs, and research reports. Anytime a problem feels heavy, use the plan then solve framework to get the right answers. Now let's move to the second technique, decomposition prompting. This comes from systems engineering and first principles thinking. Complex problems are rarely solved directly. They are solved by breaking them down. For example, instead of asking, how will climate change affect food security, we decompose it into independent answerable sub-questions such as temperature, water, pests, and interaction effect. Each sub-question becomes a focused prompt. Then finally, we synthesize the results. This reduces hallucination, improves depth, and makes reasoning traceable. Decomposition is how you force the model to think like an engineer and a researcher.